With that, we come to the end of our major section where we talked about the inspections and the the approvals to be taken from the buyer. Now we will talk about the sampling methods. The sampling method is it's a precursor to inspection. Before you do the inspection, you have to decide how many garments are you going to inspect and how will you inspect the garments and at what stage or at what level you will decide whether you are going to accept the shipment or you are going to reject the shipment. So all of those things will be discussed in this section and the other subsequent sections. Now, sampling in the technical sense, sampling does not mean making of the samples. When you are making fit samples, size sets, prototypes, pre-production samples, you are not sampling, you are engaging in the act of sample making. It is loosely, sample making is loosely stated as or used as or referred to as sampling. Sampling actually means from a given number of pieces of a shipment or a lot, how many pieces are you going to take out? That is called sampling. And sampling is a term which is related to statistics. So, more things we are going to discuss in the coming slides. Now, when we see the sampling method, we'll just look at some of those basic premise based on which these sampling methods have been created over a period of more than 100 years. Now, most textiles and apparel products are manufactured in assembly line in batches. So, assembly line in batches means the same material, the same process, and the same operator, and lot of pieces are being made. 2,000, 5,000, 50,000 pieces. So these are homogeneous products. That blue blouse that we saw. So if you get an order of 5,000 pieces, we are saying all these 5,000 pieces are replicas of that blouse. So these are homogeneous products. Now, what do we mean by sampling a lot? A lot means a set of pieces. So a lot can be like 200 pieces, one lot. Lot 2 is, let's say, 300 pieces. Lot 3 is 100 pieces. There are different lots. So how do we sample a lot? Let's say there are 10 lots of the same garment. One lot is 200, one is 500, one is 5,000. So first lot has been made first. It has to be checked, it has to be inspected, and it has to be either accepted or rejected, whatever. So first lot has come, you have to do the inspection. Once that is done, then the second lot, the production process would have started. The second lot, when the second lot comes, let's say of 500 pieces, again it has to be inspected. Now, in the first lot, how many pieces were there and how many pieces will you take out for sampling? In the second lot, 500 pieces, how many pieces will you take out for sampling? That is sampling a lot, and that's what we're going to discuss. Now, sampling or taking a sample is the process of selecting items from a production lot for evaluation. Sample is assumed to represent the overall range of quality. And sampling is a critical process. Now, sampling is, see, if you have 5,000 pieces, you can't be checking all the pieces. If you're coming for inspection, as a factory, when you're making 5,000 pieces, you will have to check all the pieces. But an inspector coming from outside to check whether those 5,000 pieces are correct or not, that person is not going to check all the 5,000 pieces. They are only going to draw out certain number of samples and check for the defects and then decide whether those 5,000 pieces will be accepted or rejected. So out of 5,000 pieces, maybe the person will only take out 60, 70 pieces. And from those 70 pieces, he will be or she will, uh, assess the overall quality of the 5,000 pieces. And sampling is a critical process. If you don't do the sampling correctly, you might send a wrong shipment, a shipment which should not be sent. You might send it. On the other hand, if your sampling is incorrect, you might reject a shipment which is actually acceptable, which is of an acceptable level, but you have rejected if the sampling is incorrect. So sampling is something which is not purely technical. Sampling is based on common sense, on statistical analysis and scientific principles. And in the subsequent slides, you will realize why are we saying that sampling is based on common sense, statistical analysis and scientific principles. Now, sample size depends on the lot size, AQL, buyer's confidence, and type of defects. So, depending on the type of defects, major, minor, critical, buyer's confidence, if the buyer has a great confidence in you, the inspector will take out lesser number of pieces to check. And then what is the AQL? Acceptable quality level. Acceptable quality level is 1, 2.5, 4, 6, 10. Likewise, we'll see the AQL table also. And then the lot size. What is the total quantity? So, depending on the lot size, AQL, buyer's confidence, and type of defects, we decide how much will be the sample size. Now, attribute sampling is one such term, attribute sampling, in which we check the conformance to the specifications. So, attribute can be something like, let's say measurement is one such attribute. So, if you are sampling only for measurements, then we are going to check whether the garments, they are conforming to the measurements or not. That is attribute sampling. Now, when you check the measurements, some measurements will be correct, some will be incorrect. Some measurements will be incorrect by just 1 mm or 2 mm. Some will be wrong by half centimeter. Some may be wrong by 1.5 centimeter. Now, how do you decide what is acceptable and what will be rejected? So, what is the point at which entire lot becomes unacceptable to the buyer? That is what precisely we are going to see. Now, one thumb rule is that if you are taking out samples, how many pieces have to be taken out? That will be seen through the statistical table, which we will see in the subsequent slide. But another thing is that when you are taking out samples for inspection, let's say there was this order of, let's say 5,000 pieces of that blouse. We saw the blue blouse. Now, let's say there are 3 colors and there are 3 sizes. Then when you are taking out samples for inspection, you must pick out samples in such a way that you have garments in each of the colors and in each of the sizes. So blue blouse, you should be inspecting blue blouses in all the sizes. Let's say there is a white blouse also and there is a red blouse also. Red, white and blue. So you should, when you are taking out samples for inspection, you should be taking out few pieces in red, in blue, in white, in all the sizes. That's a thumb rule. Now this is again the same thing here. What we are saying is that if you have an order of, let's say, 3,000 pieces, in which 2,000 pieces are in white and 1,000 pieces are in black, then when you are taking out the samples, then you must ensure that you take out the samples in the same ratio as 2:1. 2,000 white pieces, 1,000 black pieces. So the ratio is 2:1. So when the order is in the ratio 2 is to 1, then you will take out the samples in that same ratio of 2 is to 1. And that was in terms of color wise order quantity. Now within white, let's say the ratio, size wise ratio is small is to medium is to large is 1 is to 2 is to 1. Then your sample also should contain, when you're taking out samples of white color, then the ratio should be in that same ratio, small is to medium is to large, in the ratio 1 is to 2 is to 1. This is the thumb rule. It cannot be broken. Must be followed to the best possible round figure. Now, this is something very interesting. Sample should be free of bias. Meaning to say, don't take out samples. You open the carton and you take out samples from the top. You shouldn't do that, because factories normally they keep the best pieces on top. So what we do is, ideally we take some samples from the top layer, from the top, we take out some samples from the bottom, and we take some samples from the middle. So in order to remove the bias. Second bias, only one color or size is selected. If you only take out one color, or if you only take out one size, you might miss out on any such defect that may be occurring in other color or other sizes. So that's why if you want to take out samples, which is free of bias, then you should avoid these practices. You should be careful. Now, if you look at the types of samples, one way of doing it is stratified samples. A lot is stratified into segments, homogeneous segments. So let's say there are 2000 pieces of small size, 2000 of medium size, and 2000 of large size. Then stratified samples say that, take samples from each of the sizes, and in the same ratio. That is stratified sample. That is one way of doing things. Now the second is constant percentage sample. Someone may say that we will check 1% of all the shipments, whatever is the quantity. So which means if you have an order of 100 pieces, you will check one piece. If you have an order of 1 lakh pieces, you will check 1000 pieces. Now, what is wrong with this? If you take percentages, it leads to error. Now, what is that error? The error is that if there is a shipment of 100 pieces, if you just take out one piece does not give you safety. One piece does not adequately cover the quality of the 100 pieces. And in case of 1 lakh pieces, if you take out 1000 pieces, it does not make sense. I mean, why would you want to check 1000 pieces? Randomly, if I were to check, if there are 1 lakh pieces, if I take out about 150 to 200 pieces, randomly from different cartons, different sizes, all the colors, I'd still be able to make out whether this shipment is acceptable or not. I don't have to take 1000 pieces. But in case of 100, if you are just taking 1%, that 1 is very less. So if you use common sense, I'll do at least 10-12 pieces if the shipment size is 100. If there are 1 lakh pieces, I'll take out somewhere around 120, 150 pieces, and I'll still be able to gauge the true quality of the shipment. So, in the first case, inadequate protection for small lots and too much protection for large lots. When you can do things in 150 pieces, why check 1000 pieces? That is too much protection. And if you just check one piece out of 100, that is inadequate protection. Then we have systematic sample. Systematic sample says you check the first piece, then you skip 5 pieces, you check the 6th piece, then 11th piece, then 16th, then 21, 26. So this is like arithmetic gap of 5 pieces. This systematic sample happens in case when, let's say, you're doing Bisleri bottle, or if you're doing, let's say, underwear or banyan and things like that. The same thing being made continuously year over year over year. Every day the same banyan is being made. So in that case, the quality inspector, what does the inspector do? Checks every fifth or every 10th or every 20th sample to see whether it is correct or not. If something goes wrong, then they'll start checking more number of samples. If everything is okay, again they'll start skipping 10 pieces and checking 11th piece, 21st piece, 31st piece. That is an example of systematic sample. And which is like, equal space intervals or equal intervals of time. Now, it could be systematic sample. One was, every fifth piece or every 10th piece you are checking. That is one. Second is equal space intervals. So equal space intervals or equal intervals of time is that after every 1 hour, you check 10 pieces. So every hour you are checking 10 pieces, or every day you are checking 20 pieces. That is equal space interval or equal intervals of time. And this is used when same product is being produced for months at a time. Basic staples like, socks or undergarments as in men's underwear or banyan, same style, color are changing, nothing much. So it is considered a basic staple item. So the same thing produced, on and on and on for months. So in that case, systematic sampling it makes sense. It gives a great. Now let's look at the sampling plan. The big question is how much or how many to select so that we are truly checking the quality of the entire shipment. We are not going to check all the pieces. If there are 1 lakh pieces, we are not going to check all the 1 lakh pieces, but I have to ascertain that the correct quality will be sent. So how do you do that? Now there is something called acceptance sampling. Now what happens here is that inspection and evaluation of sample products selected from production lots for predetermined and defined quality characteristics after the product has been produced. So the shipment has been made. We have a predetermined and defined quality characteristics, stains, holes, color mismatch, checks not matching, measurements, and things like that. So the inspector is going to look for all those predetermined and defined quality characteristics from the selected production lot. Let's say the production lot is 500 pieces. So from those 500 pieces, how many pieces will be taken out for inspection and what will be inspected? What will be checked? So inspection and evaluation of sample products selected from the production lot for this. Now this is your acceptance sampling where we can accept or reject the shipment. Now in this slide this is one portion of the table. Now there is normal inspection, there is tightened inspection, and there is reduced inspection. A tightened inspection is where the inspection is very tight. More number of pieces will be checked. Normal inspection is where the buyer has certain amount of confidence in. Reduced inspection is where the buyer has utmost faith in you, and therefore the inspection is very less, and you are known for great quality. Now this table that you see it represents reduced inspection. It has a single sampling plan. AQL is 2.5 and the general inspection level is 2. I want to explain all of them. Now reduced inspection. So this is the case where the inspection is very less stringent. It is very generous. Single sampling plan is, there is single sampling plan, there is multiple sampling plan or double. There is single sampling plan, there is double sampling plan. Now single sampling plan means you are going to draw out the samples only once, and based on that you will decide whether the shipment is to be accepted or rejected. Double sampling plan is you have taken out the sample once, the inspection has failed marginally. In that case, you again take out samples for inspection. This system is called double sampling plan. Now the table here, this is single sampling plan. Now what is AQL? AQL is acceptable quality level. Now AQL, when we see the actual table, the table is AQL 0, 0.1, 0.2, 0.25, 0.4, 1, 2.54. AQL 0 means zero tolerance. AQL 2.5 means out of the total shipment, we will only accept the situation where 2.5% products are defective. If the percentage defective is more than 2.5, then your shipment is rejected. If the defective is less than 2.5%, then I will accept the shipment. That is the meaning of AQL 2.5. Now, general inspection level, it has different levels 1, 2, 3. So, this table represents general inspection level 2. If you take general inspection level 1 or if you take general inspection level 3, then these numbers that you see on the slide, that would change. So whenever anyone comes for an inspection or whenever you are taking an order from a new buyer, you have to ask the buyer or the client that when the inspections are happening, what method will be used for inspection? Will it be normal inspection or tightened inspection or reduced inspection? Will you allow double sampling plan or you will only allow single sampling plan? The AQL, will it be 1, 2.5, 4 or 10? 10 AQL means relaxed, generous. AQL 2.5 is more strict. AQL 1 is more strict. And what will be the general inspection level? 1, 2 or 3. You have to ask your buyer. The buyer is going to tell you all of these things. You should never work with any new buyer without knowing what will be their basis of inspection. How will they draw out the sample? If a buyer asks for an AQL of 1, then you should charge more. Because if you give great quality, you will have to spend more. So if you spend more, then you will have to charge more. Now, any buyer like an H&M or a Zara, which is mass market, and they sell at very low prices, they cannot demand for very high AQL. So they'll ask for an AQL 6 or a 4. They cannot ask AQL 2.5 or 1. It is not possible. For the type of price that they are giving, you will not be able to give them AQL 1 or 2.5 because then you will be losing from your own pocket. So this is the one particular situation. This table is based on this particular combination of reduced inspection, single sample plan, AQL 2.5 and general inspection level 2. Now, this table that you see over here is single sampling plan. The inspection is normal. The ANSI ASQ standard Z 1.4 2003. And this table gives you the sample size code letters. Now the sample size code letters is in terms of A, B, C, D, something like that. Now below the sample size code letter, you will see there are lot size 2 to 8, 9 to 15, 16 to 25, 26 to 50, and the last one is 5 lakh 1 and above pieces. Now if you take, let's say, a lot size of 2 to 8 pieces, and if the general inspection level is 1, then the sample size code letter is A. If you have a lot size of, let's say, 281 to 500 and the general inspection level is 3, then 281 to 500, general inspection level 3, the letter that is given is J, J for Jacob. So this particular table will give you the sample size code letter, which is an alphabet. So general inspection levels, if there is general inspection level, you will have 1, 2, 3. So You have to ask which one, two, or three. And then there is special inspection level, which is S1, S2, S3, S4. So depending on whether it is general inspection or special inspection and which level, 1, 2, 3 or S1, S2, S3, S4, you will then be able to decide, you will be able to find out what will be the sample size code letter. So you have the quantity on one side and you have the general inspection level on the other side, 1, 2, 3 and special inspection S1, S2, S3, S4. And to just reinforce it, if you have a lot size of 16 to 25, which is the third row, 16 to 25, and if your general inspection level is, let's say, 2, then your alphabet is C. 16 to 25, general inspection level 2 gives you the code C, C for calculator. Now you have the so-called most important AQL table, acceptable quality level table. Now in this table, once you have got the code from the previous slide, now you can see what will be the sample size, how many pieces have to be taken out, and after taking out the pieces, the inspection will be done, and based on the total number of defects, it will be decided whether you will accept the shipment or you will reject the shipment. Now there are a lot of things that we can see in this table. Now the left first column is the sample size code letter. This letter you get from the previous slide. Now the sample size 2, 3, 5, 8, 13, 20, that is the list, that is the sample size which is corresponding to the sample size code letter. So if you have an A, sample size means 2. If you have a B, you get your sample size is 3, and likewise. So the first two columns done. Now we shift to the right side. Now we have the acceptable quality levels, and this particular table, AQL table, is for normal inspection. Single sampling. If you take double sampling, then this table will change. Similarly, if instead of normal inspection, if you have tightened inspection or if you have reduced inspection, again this table will change. So right now, we have single sampling plan, we have AQL normal inspection. And normally this table is used in the industry. Now, we have just below the acceptable quality level normal inspection, just below that, we have 0.065, 0.1, 0.15, 0.25, 0.4, 0.65, and the last we have 10. As we are moving from left to right, you can see that if you have an AQL of 0.065 and if you are taking out, let's say, 80 samples. In 80 samples, if there are no defects, then it will be accepted, and if there is one defect, it will be rejected when the AQL is 0.065. But if you have taken out 80 samples and your AQL, the buyer is giving you the AQL of 10, it means the buyer is saying that if 80 pieces are taken out for inspection and if there are 14 defectives, if there are 14 pieces which are defective, till then, from 0 to 1, 2, 3, 4, 5 till 14, if there are 14 defectives, we'll accept it. If there are 15 defectives or more, then we'll reject it. So AQL 10 is relaxed. From 80 samples, 14 defectives, you are still safe. If there are 15 defectives, then your shipment will be rejected. But if the AQL is 0.065, in that case, if 80 samples have to be inspected, 0 samples Zero defectives are allowed. Even one defective means it will be rejected. So what we are saying here is, if you have an AQL of 4, it is relaxed. If you have an AQL of 6.5, it is more relaxed. If you have an AQL of 10, it is all the more easy for you. So as the quality decreases, your AQL increases. AQL 10 means relaxed quality. And so which means that any buyer which is giving you very less price, you should not agree for inspections at very low AQL levels. Then you should fight for AQLs which are high, because they are not paying you so much price. That's why. Now, if if from the previous table you got the alphabet E for elephant, then the sample size is 13. You have to take out 13 samples to check. Now, if you have an AQL of 6.5, in case the AQL is 6.5 and your alphabet is E, then if you move horizontally from E, then at AQL 6.5, 2 rejections you are safe, 3 rejections your shipment will get rejected. But if you have an AQL of 10, then 3 rejections you are still safe, 4 rejections your shipment will be rejected. So this is the meaning of this table. So there's a lot of information that has been shared here. We will take an example in the subsequent slide and make it more lucid. Now, what is the acceptance or the rejection level? Now, for example, we take a production lot of 500 pieces. Now, where does this 500 pieces fall in? So, when you see the lot size, there is 2 to 8, 9 to 15, 16 to 25. So, your production lot of 500 pieces is going to fall under 281 to 500 pieces. If it was 501 pieces, it would have gone to the next row, which is 501 to 1200 pieces. If your production lot was, let's say, 600 pieces, it would have fallen in that 501 to 1200 pieces. So here we have the production lot of 500 pieces, which falls under 281 to 500. Now, general inspection level has been stated as 1. So you can go and see, we have general inspection level and you have special inspection levels. Now we want to see general inspection level 1. Now your production lot was 500 pieces, which is falling under 281 to 500 pieces. General inspection level is 1. So the alphabet that you are getting is F. F for France, right? Now sample is equal to 20 pieces at normal inspection. Now if you go to the next table, the equal table, in that against F, you will find F means 20 pieces. And the buyer has said that I am going to take the shipment at AQL 0.65. So the quality inspector will take out 20 pieces and check. But after how many defectives will the quality inspector reject your shipment? We will see in the next slide. Now we can see that F, sample size code letter F, means sample size is 20. Now the buyer has given you 0.65. Now if you see 0.65 against F20, you have 0.1. Now 0.1 means if all the pieces are okay, then it is acceptable. If even one piece is defective, then your shipment will be rejected. So the inspector will refer to the previous table, will get the letter F. From the F, we are getting the quantity 20, and we are at AQL 0.65, we are getting 0.1. Now 0.1 simply means 0 rejections, you are okay. If there is one rejection, one defective, your shipment is rejected. You will have to open the shipment, recheck again, and offer for re-inspection. That's how we decipher this table. So with that done, a standard product is one that meets all specifications and firm's requirements. Measurement, fit, quantity, quality, color, everything. Now sometimes acceptable lots get rejected and sometimes inferior lots are accepted. It may happen that using this statistical table and scientific principles and common sense, based on which the equal table has been made, sometimes something which should be rejected gets accepted, and sometimes something which should be accepted gets rejected. Meaning to say that if 10 pieces were rejected, you were safe. If 11 pieces were rejected, your shipment would be rejected. Now, you might be very unlucky on a particular day that all when the inspector took out samples from various cartons, most of the rejected pieces got out. I mean, the inspector took out such pieces in which the defectives are there. You may get unlucky, although uh, although looking at the entire shipment, it would have been accepted. But somehow, whatever pieces were taken out from the inspector, most of them got rejected, and your entire shipment got rejected. That is called alpha, which is supply risk. That is type 1 error. The case where inferior lots are accepted, something is inferior, but all the random pieces which were selected by the inspector, all of them are perfect. Although in the entire shipment, the number of defectives are more than what will be acceptable to the buyer. But somehow this supplier, this factory got lucky. So the inferior lot got accepted in the inspection. This is called beta, which is the consumer risk, and this is called type 2 error. Now, something which should have been accepted but got rejected, that is a supplier risk. Because the factory gets, I mean, the factory will suffer. That's something which they made correctly and yet it got rejected. Beta is called the consumer risk. This is the case where upon inspection, the shipment got accepted, but there were a lot of inferior, incorrect pieces in that lot. But ultimately, all the pieces, correct or incorrect, someone is going to buy them. That falls under consumer risk. Now, the consumer risk is deadly because the consumer today is going to take your happiness if they get any wrong piece. That is the consumer risk. So, you should pray that your shipment, if your factory has made a wrong shipment, it should get rejected. You shouldn't pray that it should get accepted because ultimately someone is going to catch it. And when the customer catches it, the penalties are very, very high, very severe. Now, retailers are concerned with beta risk. Beta risk as in wrong pieces going in the hands of the consumer. And suppliers are more concerned with the alpha risk because the alpha risk is where your correct shipment will get rejected. So, why do we actually do sampling? Sampling is the process of taking out lesser number of pieces in a scientific manner so that we are still able to gauge the quality of the entire shipment. So the advantages of sampling is it is economical. You have to check lesser number of pieces. Second is the destructive testing. Now imagine button tensile strength. Now button tensile strength is there's a men's shirt. Men's shirt has buttons. Now, when we are testing the button tensile strength, the button has been attached to the shot. With the help of a machine, we pull the button. It's called the button pull test. We pull the button and we break it. So when we break it, we actually destroy the entire shot. When you tear it, the shot is of no use. So when we are doing this destructive testing, button tensile strength, if you do it on all the shots, you will have no shipment left. Then what are you going to sell to the customer? So when there is destructive testing and there are 5,000 pieces, I am only going to do destructive testing on 5-10 pieces. And those 5-10 pieces are definitely destroyed by doing this button tensile strength. So I cannot afford to destroy more than 10 shots in a shipment. Similarly, flammability. Flammability means you have to burn the fabric and check whether how fast it is catching the fire. You can't be burning the entire shipment to check the flammability. Therefore, also sampling comes handy. Sampling is of great help. And 100% inspection. Let's say you have a white blouse, very great quality fabric, great white. If you check all the white pieces, all of they are going to get dirty, soiled, and a lot of pieces may also get damaged because you are taking out all the pieces. It does not make sense. And sampling improves delivery schedules. Because you are doing sampling, you are only taking out random samples, which does not take much time. Therefore, it helps you to do things fast, and therefore you are able to deliver faster. So sampling improves delivery schedules faster. And of course, if you're doing sampling, there are some advantages. We also have some disadvantages. Now, what are the disadvantages? The first that we talked about was alpha and beta risk, the supplier risk and the consumer risk. Second is because you are only taking out, let's say, 20 pieces in out of 500 pieces. If you're taking out 20 pieces out of 500, there are 480 pieces which you have not checked. So checking 20 pieces in no way represents checking all the 500 pieces. So sampling provides less information than 100% inspection. But then it's okay. You can't be doing 100% inspection. It takes a lot of time and money, and then again a lot of work after the inspection has been done. And uh, the disadvantages of sampling, there is a possibility of an inferior product reaching the consumer. There is a certain possibility, which is greater than 100% inspection. If you check all the 100% pieces, you will catch all the inferior products, and therefore no inferior product will reach the consumer. But in case of sampling, there are chances of inferior product reaching the consumer, which is the beta risk. Also, the disadvantage of sampling is that sampling is not an entertainment. It is not an interesting task. The inspection can be a very tedious and boring process, and we will see how and why. And I want all of you to be very, very attentive and careful right now, because the moment I click the next button, there will be something in front of you. You have to read it and you have to do some calculation, a simple one. You just have to count. So wherever you are, please be there in front of the screen and count. Read the next statement, and I'll give you time only to read the statement once. You have to count the number of F's present. Read it and count the total number of F present. So further, let's look at the further disadvantages of sampling. It is tedious and detailed nature of inspection can create boredom. Oftentimes, what happens is that when an inspector comes for inspection, when they start the inspection, they are full of energy. So they will you might find them finding faults in everything. But after half an hour, 1 hour, 1.5 hours, you will see that they have slowed down. They've started accepting minor defects. They are accepting it. They're not even writing down that it's a defect. But when they started, they were being very, very strict. So it's something which happens. It's human. And yeah, so board inspector may miss a critical element. They may miss a critical element, or they tend to start accepting a lot of faults. That's fine. It is okay. And by the way, how many Fs did you count? So you guys were already bored and you counted 18. Someone did not even count, and one of them counted 19. Yeah. So some inspectors count too few. We had someone who didn't count, and there were some who counted a little less, and there will be some who would count too many. And that is what happens in sampling. That is what happens in inspection.